Hello and welcome back. In this section, we are going to discuss AWS's service called DynamoDB in detail. We are going to use this DynamoDB at a lot of places in our course, and that makes it really important for us to understand how this DB works and what are the different features and what are the core concepts on which this database is designed. Now, Amazon DynamoDB is a fully managed NoSQL database service that provides fast and predictable performance with seamless scalability. Now, what does this all mean? The first thing we want to understand is how is it fully managed. So we hear about this term a lot in serverless environment or cloud-based environments that services are fully managed. So by fully managed, what we mean is that we don't have to worry about hardware provisioning, setup and configuration of services. In this case, DynamoDB. AWS takes care of all the provisioning, setup, configuration for us, and we don't have to worry about backend or underlying hardware that AWS uses and scales as per the load of the application increases. So things like replication, software patching, taking care of the security bugs and issues, and also cluster scaling is taken care by AWS. DynamoDB also manages the encryption at rest for us. We can simply choose the encryption keys provided by AWS or upload our own keys and just enable encryption at rest feature, and rest of the encryption and decryption is taken care by AWS. DynamoDB also is able to store and retrieve any amount of data and serve any level of request traffic. So theoretically, there is no limit to the amount of data that we can store under DynamoDB. AWS will keep on scaling the underlying servers or partitions in this case as the traffic or load on the application increases. So in that way, the database is fully managed. We don't have to manually provision any servers or ask anyone to increase or decrease underlying hardware resources for us. Now, what do you mean by seamless scalability? So in DynamoDB, you can create an application auto scaling policy for your table and scale up or scale down your table's throughput capacity without downtime. So we don't have to shut down the DB or shut your application to increase or decrease your throughput capacity, thus making the database seamlessly scalable. So your website will not undergo any performance degradation when you're taking backups or restoring your database to a point in time recovery, scaling down or up your read or write capacity units. DynamoDB also allows you to delete expired data by setting time to live value. So let's say if you want to delete your data which is more than 30 days old and your application does not need it, so you can just set this time to live or TTL value, and DynamoDB will keep on discarding the old data, thus reducing your costs. You can of course monitor your table resource utilization and performance metrics using AWS's CloudWatch. DynamoDB also allows you to create a global table. Now, it means that you can have one table with multiple replica tables, one per AWS region. And in each region, your DynamoDB will replicate your data across multiple availability zones, thus making it highly available throughout the globe. And this allows the database to deliver quick local read and write performance for massively scaled global applications. Now, DynamoDB is a NoSQL database, which means there is no rigid schema or it is schemaless. Now, every table must just have a primary key to uniquely identify each data item in the table. Unlike a SQL table where it needs a well-defined schema where data is normalized into tables, rows, and columns. In addition, all of the relationships are defined among tables, columns, indexes, and other database elements, whereas in DynamoDB, because it is schemaless, There is no similar constraints on other non-key attributes. And DynamoDB can manage structured or semi-structured data, including JSON documents. Now, NoSQL databases are generally for web scale applications where application starts with less number of users, and with time as the workload increases, it gets easier to scale a NoSQL database like DynamoDB instead of a schema-based database where scaling up the database means getting a faster hardware, and relational databases always have some maximum sizes for the number of files you can store and the size of the files you can store. So there is always an upper limit to scalability. Whereas DynamoDB is designed to scale out using distributed clusters of hardware. Now this design allows increased throughput without increased latency. Right? So customers specify their throughput requirements at DynamoDB because it is fully managed, allocates sufficient resources to meet those requirements, and there is no upper limit on the number of items per table, nor the size of that table. So all the modern applications like social networking sites, gaming, media sharing sites, and IoT based applications are perfect use cases to use DynamoDB. Whereas if you want to do ad hoc queries or data warehousing, then RDBMS or a SQL database makes more sense. Now DynamoDB is really fast. You can expect to get single digit or less than 10 millisecond latency performance, and this is available at any scale. So AWS guarantees that no matter what scale your application is going through, you can still get less than 10 millisecond performance for your queries. In certain use cases, you can also use DynamoDB Accelerator or DAX service, which provides latencies in microseconds and provides really fast response times for your application. Now only eventually consistent data is currently supported with DAX or DynamoDB Accelerator service, so that's something you need to keep in mind. Now let's talk about how DynamoDB stores data in tables. Now DynamoDB stores all your data in partitions. Now partitions are storage allocation units which are backed by SSD drives. So one SSD drive can have many partitions. So you can think of partitions as virtual units of allocated space on SSD drive. Now DynamoDB spreads the data and traffic for your tables over a sufficient number of servers. Of course, each server will have multiple different partitions. Now the data is replicated across multiple availability zones in an AWS region, and you can also have multi-region data replication via global tables. Now all of this, the storage of data and scaling of partitions, which actually stores your data in a table, is fully managed by AWS. So you will never have to manually create partitions or SSD drives or write logic to spread your data and handle all the traffic across different servers. This is all fully managed by AWS. Now this is a very high level view of how storage of data happens in partitions. In next few lectures we will see the whole process in detail. Well, that's all for this lecture, and I'll see you in the next one.